Today we're doing section 4.4. We're going to be discussing reference angles, and this is the first day we're going to be discussing reference angles. So a reference angle is an acute angle created with the x-axis. So I'm going to show you two ways to do this. Either you can memorize the formula or you can just kind of think based on the placement of the angle. So obviously if you're in quadrant 1, there is no reference angle because acute means the angle has to be less than 90 degrees. If my angle falls in quadrant 2, the way we find the reference angle and the way we denote the reference angle has a little tick next to it is 180 degrees minus the angle. Okay, and this spot right here would be our reference angle. If you're in radians, it would be pi minus the original angle. If we are in quadrant 3, the way we find the reference angle is the original angle minus 180 degrees, or pi, to find this angle right here. And if we are in quadrant 4, my reference angle would be located right there, and the way we find the reference angle is by doing 360 minus the original angle. Okay, so either you can memorize the formulas, or if you kind of look at the picture, again, your goal is to always find the distance between the angle to the x-axis. So I think it's easiest to kind of draw a rough sketch. So 345 degrees would be falling in quadrant 4. So this would be 345 degrees. My reference angle would be this angle right here. So if I'm using the formula, I'm doing 360 degrees minus the 345. And when I do that, I'm left with 15 degrees. So that would be our reference angle. So you can either use the formula or, like I said, you can just kind of think about it. You know this is 360, you know this is 345, so the difference between the two would be 15 degrees. Letter B. Again, we're going to graph it, so remember, graphing angles, this would be 6 pi over 6, which means up here would be the 3 pi over 6. So 5 pi over 6 would be falling closer to the x-axis. And if I'm just looking at it, the distance between this reference angle here and the x-axis would be a positive 1 pi over 6. You can do it that way, or if I'm using the formula, it would be 180 minus the angle. In this instance, because we're in radians, it would be pi minus the angle. I'd have to get common denominator, so this would become 6 pi over 6. And again, we get the 1 pi over 6. So whichever way makes more sense to you is the way you can proceed with these problems. Letter C, we have a negative 135 degrees. So a reference angle is always a positive acute angle. So we're always looking for the positive distance. So negative 135 falls in quadrant 3. We know that this is negative 180, so if I need to find the distance between the two, I would subtract these values. So I have 180 minus 135, and when I subtract them, I'm left with 45 degrees. So my reference angle is a positive 45 degrees between those two spots. So go ahead and try the practice problem of the reference angle 7 pi over 6, and go ahead and input that into the video. So the last two examples, same deal. The only thing that's different is that these angles are very large. So these are past the 360 or past the 2 pi mark. So first thing that we would do is determine a coterminal angle. So remember, coterminal angle is adding or subtracting 360 or adding or subtracting 2 pi. So because my ultimate goal is to find a reference angle that is acute, meaning less than 90 degrees, I would be subtracting the 360 from this angle here. So when I do the first round of subtracting, 220 degrees is in the same location as 580. So let's go ahead and draw it. 220 would be falling in quadrant 3. So 220 degrees is there. 180 degrees is at that spot right there. So our reference angle, the distance between these two angles, would be 40 degrees. So we found coterminal first, just so that I don't have to figure out how many times around it goes, and then we graph it. So same thing for this one. 8 pi over 3 is larger than 2 pi, so a cutoff with a denominator of 3 would be 6 pi over 3. So this is definitely larger, so I do want to find coterminal, so I'm going to be subtracting a 6 pi over 3. And again, this is 2 pi, I just got common denominators for my subtracting sake. So when I subtract it, I get 2 pi over 3. So I know over here is 3 pi over 3. 1.5 pi over 3 is up at the top. So a 2 pi over 3 would be a little bit closer to the y-axis. And we're looking for the reference angle created in this space right here. So my reference angle would be 1 pi over 3. All right. That's all for today. We'll go over this video and this content tomorrow.